equal things is the addition property. And this is a property of equality, and whenever we have a property of equality, we can just abbreviate that as POE.
Poet.
And so the addition property of equality is a conditional statement. If A equals B, then addition says I can add stuff, right? So I can add C to the left side, but to keep it equal, I have to add C to the right side. That's the addition property. I can add the same thing to both sides and it will still be equal. But that only works if they started out equal. Okay? Questions on the addition property? Yeah, that's your golden rule of math. Do unto one side as you do unto the other. Any guesses about what the subtraction property of equality would say? Jane, what do you think?
If A equals B, then A minus C equals B minus C.
Then A minus C equals B minus C. Oh, I can subtract the same thing from both sides. Exciting. And it's still equal. Next victim. What do you think the multiplication property of equality says? Olivia?
If A equals B, then A times C.
Then what?
Then A times
And equals? B times C. Notice I didn't bother putting the times because when letters are next to each other, that means they're multiplied. So I'm not going to bother writing what I already know. Division property, Dasha?
If A equals B, then A divided by C equals B divided by C.
There you go. Notice I wrote them as up and down using the fraction bar as my division bar. We do not like to use this little division, short division symbol from elementary school. That's like a crutch for little kids. We don't use that anymore. We use the fraction bars. Learn them, love them, live them.
Is it fine if we did like A slash C?
Slashes are technically correct, but when you start getting into more confusing stuff, especially next year, that's going to just make life garbage. So I recommend just getting used to doing it with horizontal bars, okay? Ooh, and then we're going to start changing things up. Substitution property. Somebody tell me what you do when you substitute something.
You take something?
Yes, Caleb?
Put something in the place of something else.
Put anything in the place of anything else? Or is it good if the thing you replace it with is kind of the same?
Yeah.
And you wouldn't want to put a squid to be my substitute, right? You'd want probably at least a human being to be a substitute?
Yeah, probably.
Yeah. So for the substitution property, we say that if they are equal, then A can be substituted for B.
True.
Okay? You have to be equal to be a substitute in math. We don't just replace stuff willy-nilly. Yes?
Like, for example, you wouldn't substitute an English teacher with a math.
Well, actually, when we substitute, sometimes we have to for a day.
But if you can choose. Then
Oh, yeah. That's how I started teaching back in '97. I took some time off to be with my kids, and then when I came back, the first thing I did was substitute for a while, so I could try out all the schools. And then I found this school, and I was like, oh yeah. So they had an opening for a teacher, and I was like, shh, just went right in there. Distributive property. Y'all know this one. This is the only one that's not written if-then. Okay? This one just tells you the two different ways a thing can look, and you just have to know that that's what happened. So if you have something that looks like this, the distributive property says that's the same thing as if you did the first, multiplied the A times the B, and multiplied the A, I'm going to write this correctly.
Believe in you.
Yeah, but I don't believe in my whiteout. It's like being garbage. Then A times C. So I can, multiplying both things individually is equal to having it on the outside. Okay? Basically, you can distribute and it's still equal. Okay? But it's written this way for a reason. And guess what you have just done?
Algebra.
You have just learned the rest of the implied statements on the first page. So let's see, well, they're properties, not implied statements, but you know. The addition POE looks like this. The subtraction POE looks like this. And so when you learn these guys, you're basically going to be learning what you wrote down here. So when you see addition POE, you should be able to write this whole thing. If you see subtraction POA, you should be able to write this whole thing. That's how we're doing those ones, because they're not really implied statements, but they're on our list. You need to memorize them. Know them, love them, live them. So the way we use this in algebra is you've already done this in your last couple of years. Now you're just going to write the reasons as you go. So when we do a proof, the first thing we write is the stuff that we were given. So I have this problem. Solve 2x plus 5 equals 20 minus 3x. What did they give me here? They gave me the whole equation. So whatever they give you goes first. So I'm going to put 2x plus 5 equals 20 minus 3x. And how am I allowed to put that as my first step? It was given. And so you put given. Given always goes first.
It was given to us by the math god.
The math gods have spoken. That is what we are being given for this problem. And then you look at that and you think about all the different properties that you know, and you think, what's something I could do to this to try and solve for x? Trin? How do you move the 5? Oh, I could minus 5 from both sides. And if I did that, that would give me 2x equals, what, 15 minus 3x?
Yep.
Now, since it's a proof, you have to tell me a reason that you were allowed to do that. Why was I allowed to subtract 5 from both sides and call it good? Let's see, Marcus, you look like you know the answer. Which of those properties lets me subtract 5 from both sides?
Subtraction
The subtraction property. Now, guys, notice that subtraction and substitution are really similar looking words, right?
Yeah.
So when you write it here, don't just put sub. Because I don't know if you mean substitution or subtraction. So maybe put a couple extra letters, subtraction, property of equality, just so I can tell you meant subtraction and not substitution. Okay? Subbed. Okay, now you look at this, and you think back to all these properties you have, and what's something else you think one of those properties would let you do here? Caleb?
We can add 3x to both sides.
I sure could.
With the addition property.
And so that's going to give me 5x equals 15. And oh look, since I added the same thing to both sides, he says that's the addition property of equality. And no one will kill you to write POE, so go ahead and put it. Don't just put addition. Yes?
When we're doing proofs, will we keep it in like algebra stuff? Or will we...
Well, no, we're starting you off on algebra because you already know it. Don't worry, geometry comes on the other side.
Geometry.
Then, what could I do from here based on the properties I know? Ben, what's something that looks like I could do now?
Divide by
Okay, divide by 5 and divide by 5. And so x equals how much? And what property let me do that step? Division. Property of equality.
Cool.
That, my friends, is called an algebraic proof. Are you impressed?
Yes. Not really.
Okay, I'm going to give you a couple of minutes. Attempt the next fella. You can work together. Talk to each other about it. And so what you would probably do is you would do write your given. So you would put 11x plus 2 equals 80 because that was what you were given as your problem. Then you could look at this and say, oh, I have something written with parentheses, so I can rewrite it this way and write it as negative 44x minus 8 equals 80. And the property that let me write it a different way is the distributive property. Then I can look at this and say, oh, you know what, I bet I can add 8 to both sides. Another thing you could do on this step is divide everything by 4. And it doesn't matter what order you do it in. I'm going to choose to add 8 to both sides, which will give me negative 44x equals 88. And since I added to both sides, I know I used the addition property of equality. Then, I see that I have multiplied by negative 44. I can divide both sides by that same thing to get x equals negative 2. And since I divided both sides by the same thing, I know I use the division property of equality. Okay, so I finished. Does yours look like mine?
Yes.
Did anybody do any steps in a different order? Did anybody divide instead of distributing? Because see how it's 4 times parentheses?
Yeah.
Could I have come over here and just divided everything by 4 and had 11x plus 2 equals 20? Could I have started out doing it that way? Oh, sorry, negative 20.
Yeah.
I could have. As long as I can back it up saying I used the division property, that would be good. When I was at this step here, could I have divided by the 4 here before I added the 8?
Yep.
Yeah. Order doesn't, as long as you're following the rules and doing something legal, there's not just one way to do a proof. So just make sure you're following the rules and you'll be fine. Okay, turn it over. Here's where you get to have to pay attention to the difference between numbers and objects. When you say equal, you better only ever be talking about a number.
Or else.
If you're talking about a thing, not a number, then you have to use congruency. Okay? And so here's how those look different from each other. Okay? So first let's start off with a new property. This is called the reflexive property. And the reflexive property says you are equal to you, or you are congruent to you. Think about that. Are you the same as the person in your reflection?
Yeah.
Yeah.
I mean, no.
No, you look exactly the same.
Reflected.
Yeah, it looks just like you.
Yes.
So you are equal to that. Okay? Let's don't overanalyze our things. It's a mnemonic device, y'all.
Philosophy.
Okay? So, so for numbers, whenever everybody's done chitter-chattering, so for numbers, that might look like, remember how A, B, and C are real numbers? Some number equals a number. It equals itself. What about if I'm talking about the length of a segment? If I had segment AB, could I put segment AB equals segment AB here?
No.
Because this is only numbers. How do I show the length of AB? Because length is a number.
Just do AB.
I could say AB equals AB. Because when you don't put the bar, you are talking about the length. And length is a number.
What did you just write?
Length and AB equals AB.
Sorry.
What about if you have an angle measure? How would I show that angle measures are equal? Like 45 degrees equals 45 degrees. Yeah?
The measure of angle.
I would have to say the measure of angle P equals the measure of angle Q. You have to put those ends when you say equal. If you don't put them there, I will remove points from whatever you're working on. A lot of you would have lost points on your test, even more points, if I had paid attention to angle symbols, measures, congruence, equals, degree signs. A lot of you left stuff off. Next test, full bore, taking it all. So for congruency, it still holds true. You are congruent to you. But now we're talking about objects. So our object might be this segment, and you could say segment AB is congruent to segment AB. It's congruent to itself. And you're like, well, duh, that's obvious. Yes, that's why it's a property. Properties are the obvious things you can see about stuff. How would that look like with angles? Jane?
Angle is
is congruent to angle Q. We don't put the measures. Yeah, okay. Just put that by my keyboard up there. Thank you so much. All right. So that's the reflexive property. Reflexive means you are congruent to you or you are equal to you. Yes?
You wrote equals equals.
I left off the congruent. Bruh, get the candy. Good for you.
Is it fine if we do like angle 1 and angle 2? Because that's the other.
Yes, as long as you say angle and not measure of angle. Because that's a different way of naming it, and that's fine. Okay, so the symmetric property now can go with these. Symmetric property says if two things are equal, you can write them in either order. So for like a plain old number, you could say if A equals B, then B could equal A. Okay? They're the same no matter which one you write first. It's symmetric. And it kind of even looks like, like if you have butterfly wings, the same part is in the middle, and then the matching part is on the outside of both. Okay? Same things are in the middle, same things are outside. So it's symmetric. People mix this up with reflexive all the time. So remember, with reflexive, it's you equaling you. These are two different things that are being said to be equal. Okay? So if you had a segment, you could say if the length of AB equaled the length of CD, then what would the symmetric property tell us?
CD equals AB.
CD would have to equal AB. It's symmetric. Forward and backward, it works the same. Equality works that way. And so if the measure of angle A equals the measure of angle B, then what would the symmetric property tell you? Symmetric says you can reverse them. So it's the same forward and backward. So what could you say? Somebody answered one for me. New victim. Yes?
Measure of angle B equals measure of angle.
Yes, exactly. It doesn't matter what order you write it in if they're equal. Okay? So, again, that's for numbers. So when you get into objects, the symmetric property also holds true for congruent. So if you're talking about segments, you could say, instead of equals, you could say segment AB. If segment AB is congruent to segment CD, then what would the congruence, symmetric property of congruence tell us? Yeah?
That segment CD is congruent to segment AB.
There you go. So here, because I said congruent, I have to put the bar on top of it to talk about the object. Here I'm talking about numbers. Congruence is talking about objects. So with angles, if angle A is congruent to angle B, then angle B better be congruent to angle A. Different things being equal can be written in either order. And transitive, I touched on transitive property a little bit when we talked about the law of syllogism. This one says, if I have A equal to B, and it turns out that B also equals C. What do you think you can say, thanks to the good old transitive property? Mehdi?
A equals C.
I can say A equals C. I can leave out that middleman and jump straight to here. It's called the transitive property. And so with segment lengths, if AB equals CD and CD equals XY, then what would be true? AB would have to equal XY. For congruent, that same statement would look almost the same, but we would be talking about segment AB being congruent to segment CD, and segment CD being congruent to segment XY, then segment AB could be congruent to segment XY. And now it all starts to feel like alphabet soup. Does this work for angles as well?
Yes.
Yes. Angle measures would be equal. Angles themselves would be congruent. So if A is congruent to B and B is congruent to C, then A is congruent to C. Okay? It's all the same stuff written in different ways. And lucky you, you have now learned all of the properties and implied statements for chapters 1 or units 1 and 2 all the way through number 35.
Wait, so whatever.
So our next implied statement quiz, which will be on Monday, September 12th and Tuesday, September 13th, any of these 35 could be on it. And I gave back your old ones already, right? Yeah? Okay, good. Now you know which ones you need to study, plus all the new stuff. When you do the properties, y'all, it says substitution POE, and then you're going to learn the stuff we wrote down. So if A equals B, then A can be substituted for B. Distributive property, whatever I told you to write down on here, those are your properties that you've got there. Okay? All that stuff. And your logic stuff. Conditional statement, converse, inverse, and contrapositive. You have to know how to write the symbols. That's the P's and Q's. Mind your P's and Q's that we talked about last class. Okay? So, I'm going to skip this part where you go over examples of it because y'all aren't stupid. And instead I'm going to show you how we use this in geometry. Okay? So what you have to do is you always start with what? This is stuff you're given. So look at this picture. What's something I know in this picture? Something that was given to me. Yarn?
The D and E, like, section of the line.
So the length of DE.
Is 1/3 x plus 1.
Sure, that was given to me. The length of DE is 1/3 x plus 1. What else was I given? Harry.
DF is 11.
DF equals 11. Practice using your math terminology. Oh, somebody else. Ryan. What's something else I can see in this picture?
DF is 7.
Equals.
7.
There you go. Good job. Guess what? There's one more thing that was given in this picture that's not written, but drawn. At the top of your implied statement list is a list of 4 things that you can look at the picture and just get from the picture. Vertical angles is something you can get from a picture. Do I see any vertical angles here?
No.
Dang it. I can get adjacent angles. Any adjacent angles here?
No.
Linear pair?
No.
Betweenness?
Yes.
Yes.
Oh, what can I say is between in this picture? E is between what?
D and F.
D and F. That's given as well because it's given in the picture. It's implied from the picture. So they gave us a lot of junk here. And so this is where knowing your implied statements helps. Because you're like, what will this lead me to do? What am I allowed to take from this? Now think of your implied statements. What does betweenness imply?
The segment addition postulate.
The segment addition postulate. So I can say what segments would I be allowed to add?
D
DE
and DF.
and DF could be added to make, is it DE and EF?
Yeah.
Yeah. These 2 smaller pieces can be added to make the whole thing. What implied statement let me say that?
The
Betweenness implies segment addition postulate. That's the reason that let me write that down. Don't write it down here if you can't tell me what said it was okay. Yes?
Doesn't the arrow have both sides? Wait, on the...
Yeah, I suppose it does have both sides. Go ahead. Technically, we're only using it in one direction here, so you could just write it in one direction, because that's all we're using it for. Okay, yeah, you're going to get the candy, though, absolutely. Okay, so now that I see this, I first, I need to get what x equals. I don't have any x's here. How can I make this equation have x's in it? Well, look back at your givens. Do I know how much DE is?
Yes.
I do. It's 1/3 x plus 1. Could I replace the letters DE with the amount it equals?
Yes.
Yes, so I could put 1/3 x plus 1 plus, y'all said the EF was 7. I can substitute the EF with its number 7. And I can substitute DF with 11. What property lets me replace things with stuff that's equal to it?
The transitive.
Distribution?
Transitive.
No, think. What thing lets you substitute?
Oh, I wonder.
Substitution. And put POE because it's a property of equality. Get used to writing POE and POC a lot. It won't happen.
Keep going. Answer.
Then, what can I do here? I can combine the like terms. So I can have 1/3 x plus 8 equals 11. That one we haven't talked about yet. That one's just combining like terms. And so you can just put combine like terms. That's all you did, was you just combine, and they have to be on the same side of the equation. All we did was take two things on the same side and combine them. That's all we did. We didn't do anything that involved same thing to both sides or anything like that. All we did was combine two things that were already on the same side. Now what can I do?
Subtract.
I could subtract 8 from both sides, which would give me 1/3 x equals 3. What property let me do that move? That would be your subtraction property of equality. And notice, I can tell by what I wrote. This one's substitution, this one's subtraction. That's why you don't want to just put sub, okay, so that they look different. Last step. Next victim. Somebody hasn't said this a lot yet. In fact, I'm going to just pick a victim here. Sophia, I haven't picked on you much yet. What can I do now? I could multiply both sides by 3, and that would give me x equals 9. What property let me do that? And that's your multiplication property of equality. Okay? And so that's the kind of thing you're going to do on your homework. You're going to always write down any information they give you, including stuff you can get from a picture. And then you're going to start using your implied statements to create some math. And then once you have it written like algebra, you can use your algebra properties. All right. Now, we have advisory. Does anybody have an advisory pass that they need to use to go somewhere?
Hola.
Okay. If you're staying here, would you like me to do this other one so you can see it?
Yes.
Yes.
Okay, so let's look at this one. What do you always start with? The givens. Okay, so the left side are your statements. These are things you're saying, and on the right side is your reasons. And so the reason for the first thing is always that it's given to you. So what's something I was given? I'm given a lot in this picture. Yes, what's one thing?
Angle 2 is, the measure of angle 2 is 58 degrees.
Equals 58 degrees. That's something I was given. What else was I given? Yes.
Angles 1, 2, and 3 are adjacent.
Angle 1, angle 2, and angle 3 are all adjacent. That's something you can see in the picture. Next victim. What's something else you can see in this picture that they tell you? Yes?
The measure of angle WYX is 3 times n minus 2.
Do you mind if I just call that angle 1?
Yeah.
Okay. Measure of angle 1 equals 3 times n minus 2 degrees. And the measure of angle 3 is what, 2n minus 12?
Yep.
They also gave us all of this stuff, didn't they?
Yes, they gave us a lot.
Yes, they did. They gave us lots. Okay? I don't know if I'm going to need that yet, so for now I'm just going to put this stuff down and see what can I get from all of this garbage. Well, do any of these have an implied statement involved with them?
Yes.
Which of those things, not you, has an implied statement that connects to it? Only one person knows it. Oh, Bruno.
The measures of angle 1, 2, and 3 are, you can use the angle addition postulate.
How do I know I'm allowed to use the angle addition postulate? What implied statement?
They're
Oh, since these angles are adjacent, I could use the angle addition postulate. So I could say, which ones do you want to add? I'm trying to say that XYZ equals angle 2 plus angle 3. So I'm trying to say that XYZ equals this guy plus this guy. Okay? And so y'all are saying that the measure of angle XYZ equals the measure of angle 2 plus the measure of angle 3. Okay? And that's because, what's the implied statement for that?
Adjacent angle.
I had adjacent angles implies AAP. Now that I've done that, I want you to solve for n. I want you to find n. Yes? Hi. And you're here to take the test or finish the test? Finish, I've got it right over here. Excuse me.
Measure of angle.
Calculator only on the calculator part. So now if I wanted to take this and solve it for n, I want to find n now. What would I have to do next? Well, does my current statement have n anywhere in it?
Would you have to substitute?
I would probably need to substitute some stuff to get my n's in there. So I'm going to go, okay, what could I replace? Well, I want it to end saying, you know, so what does XYZ equal? I don't know. So the measure of XYZ is 4n minus 6. We're going to ignore that for now. We don't usually do that, but we're going to ignore it because I need to get moving. Okay? What's the measure of angle 2? What is it?
58.
It's 58. And what is the measure of angle 3?
2n minus 12.
2n minus 12?
Yes?
Okay. And so how was I allowed to put those in there? Don't answer. You've answered too many things and other people aren't even bothering to think. So you've answered too much stuff. Steven, what let me put all these n things in place of all my angles? Substitution property. Wow, y'all are so smart. Then, once I have that, now what can I do? I can combine my like terms. So I can do my 4n minus 6 equals 2n plus 56? Did I do that right?
Well, you'd be right.
58, oh no, 46, 46.
But you don't have to be physically strong to be mighty. You don't have to be pumped up and brawny.
Doing this right through announcements.
Be a man. There's an old
Okay.
Hebrew saying, who is mighty? One who makes an enemy into a
Can you even read? Yeah, that's a 4.
Making an enemy into a
Okay,
friend.
what property let me do that again?
Powerful can happen.
That's your combining your like terms.
Mighty good.
All we did was just combine stuff that was on the same side.
Make it a great day or not.
That's all we did.
It's yours. And now for a moment of silence.
So our terms are all nice and combined. It's nice and simplified. You could even write simplify if you want, as long as you're only doing it to stuff that's already together. So now that I have this, how would I go from here? There's more than one way to attack this. Yes? You could add 6 to both sides. And so you'd end up with 4n equals 2n plus 52. And what property was that, Miriam?
Remember our Highlander habit, be present.
What lets you add stuff to both sides?
You are
Addition.
present in the moment. When in the hallways, that means you should have your head up and be able to hear others talking to you.
6.
Do not have both earbuds in or headphones
All right,
on
now
so
what?
that you cannot hear. Earbuds should be worn in class
New
unless
victim.
specifically allowed by your teacher. Just a friendly reminder.
Got it. What can I do now?
Students, here in a little bit, we're going to have our September fire drill. Teachers, this would be a great time to review expectations.
I can subtract 2n from both sides and get 2n equals 52.
We'll be back on soon.
And what let me subtract the same thing from both sides?
Subtraction.
The subtraction property of equality. And then finally, Sarah, what can I do here at the end? Divide both sides and get n equals 26 using my division property of equality. Okay? So that's the kind of thing you're going to be doing. If we start you with geometry, you take the geometry properties we know, use an implied statement to get it into math, and then use our algebra properties.